Okay, ladies and gentlemen, Miss Yuko is going to try something different with your homework where you are doing more of the notes and reviewing at home and we're doing the practice at school. So you should have gotten your notebook or a new notebook from Miss Yuko, or you should be writing this on a piece of paper if you forgot. But go ahead and set up on the right side of a new sheet of paper, factors versus solutions. Draw a line towards the left. Draw a little line at the bottom, and then on the left side of the line, I want you to write quadratic equation. And this is the standard form of a quadratic equation. How do I know it's a quadratic equation? Because of the ax squared. Okay, we're going to go through an example together of f of x equals x squared minus x minus 6. We are going to factor this function first. The only way that we can factor a quadratic equation is to use the diamond method. Now, if I go too quickly at any point during this video, make sure that you stop and rewind or just pause me. Okay, so using the diamond method, we have to find A, B, and C. So in our example, the coefficient in front of our x squared is 1. Our coefficient in front of our x term is -1, and our c value is -6. We do not need to DRS. We would need to DRS if this a value was anything other than 1. Okay, so now we set up our diamond. A times C goes on top, B goes on the bottom. A times C, 1 times -6 is -6. B is -1. We are looking for two factors of 6 that are going to add to be -1. Now, you might immediately think -5 and -1, but those are not going to, or -6 and -1. That's not going to work. Let's think about how we can manipulate 2 and 3. I can't have the -2 because -2 plus 3 would be +1. So the 3 needs to be negative. I'm not done here. This is not my answer. Our third step is write the factors. We take our diamond and we use these numbers here on the sides to write our factors. Our factors in this example would be x plus 2, because this 2 is positive, and then x minus 3. All we have done is taken our expanded quadratic equation and now written the factors. How could I double check that these two factors, when multiplied together, equal our original function up here, x squared minus x minus 6? We could do the reverse of factoring. We could multiply these two binomials out. So we can check using box or FOIL. I prefer the box method. It doesn't matter which binomial goes on the top and which one goes down the bottom, as long as you keep your terms together. X times x is not 2x, it's x squared. X times +2 is +2x. -3 times x is -3x. And -3 times +2 is -6. Now we CLT. There are no other terms that are like terms with my x squared. -3x plus 2x is -6, negative x rather, and then -6 does not have any other like terms. Is that my original function that I started with? Yes. That is factoring. On another page, it could be on the back, that's totally fine. Again, I'm going to draw another line. Now, let's talk about solving. Let's use that original function, x squared minus x minus 6 equals 0. The reason why we can solve this equation now is because this equals 0. This makes this an equation. We need to find solutions that will make this statement true. There are several different methods that we can use in order to do that. The first method is graphing. You would find the x-intercepts. The second method is factoring. You would set each factor equal to 0 and solve. The third step is square roots. But you can only use square roots. You can only use it when it's x squared minus plus or minus c equals 0, when you don't have a bx term. And the fourth way is the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Circle the quadratic formula. You can always use the quadratic equation. Okay, so let's use these. We can only use 3 different methods for this example. We can't use square roots because we have this negative x term right here. So I'm going to do every single method in order for you guys to see that. So with graphing, in our calculators, you cannot put equals 0 into the calculator. You would just put this part of the equation into your y equals. So when I open up my calculator, I'm going to clear it by doing second plus 7, 1, 2, and go into y equals x squared, my calculator, minus x minus 6. Graph. I'm not going to guess what my x-intercepts or my zeros or my roots or my solutions are. I'm going to make sure I know what they are by pushing second and table. Now I'm looking for the x-intercepts. The x-intercepts are when y equals 0. When I graph my equation, I can figure out that I'm going to have 2 different solutions. I'm going to have 2 different x-intercepts. By graphing your function, you're able to determine the number of solutions. So I have 2 solutions, roots, x-intercepts. All of those are the same term. So I'm looking for the 2 places where y equals 0, not where x equals 0, but where y equals 0. So here's my first one, 3, 0. And I know that one of my solutions is negative. I can tell that this negative value is on this x-axis at the negative side. So I'm going to go back to my table. I need to go into the negative values for x. Now I see that my other solution is negative 2. Those would be my solutions when I graph. What about factoring? Now we already found the factors over here on the other side, x plus 2 and x minus 3. The only thing that's different is now we have this equals 0 portion. Now this is called the zero property rule. In order for this to be true, either this term or this term needs to equal 0, because 2 times 0 equals 0, 0 times 2 equals 0, and 0 times 0 equals 0. So one of these terms or both of these terms needs to equal 0. So that's why I said up here, set each factor equal to 0 and solve. So either x plus 2 equals 0 or x minus 3 equals 0. Now, to solve for x, we use inverse operations. So either x equals negative 2 or x equals positive 3. And these two terms can also come from my graphing solutions up here. Now we're going to spend a day going back through the quadratic formula at another time. So I'm just going to work with graphing and factoring as this introduction right now. So in summary, factors multiply to equal the polynomial. Solutions make the statement true. X plus 2 and x minus 3 were your factors. X equals negative 2, x equals 3 are your solutions. X equals, x equals. So let's try this out with practice form tomorrow. Thank you for watching.